Hello, this is Shakil Ahmed. In this tutorial, we will learn about odds ratios. Basically, in association studies, when we have two variables, qualitative variables, one with exposure and one with outcome, we see the association between these two variables. We just run a chi-square test and we get the association is significant or not. But we can't quantify the association of exposure on outcome. So odds ratio is used to quantify the effect of exposure on outcomes. Basically, when we talk about exposure, these are the risk factors of different disease. For example, simply we can say that uh, income may be an exposure or a risk factor for chronic disease. When a person has a good income, he can do checkups day on daily basis, and he will be uh, less prone to risk of chronic conditions. On the other hand, it might be the dieting habits can cause the income associated with dieting habits, and that can be associated with chronic condition. So in this example, I will just show how we can find the odds ratio between income and chronic condition. So let's come to our data set, that is the National Health and Nutrition and Examination Survey data set that consists of 2005 to 2018 of 7 cycles, and we have already cleaned the data, and we have these are the demographic variables, and we just record it, and we have the survey object that is as design, I can say. So we can just run this. And we had constructed a chronic condition counts on the basis of five different diseases: diabetes, high blood pressure, congestive heart failure, and coronary heart disease and heart attack. So on the basis of these variables, we just constructed a count variable. When a person has at least one of these disease, he is said to have a chronic condition. So chronic condition is just a binary variable constructed from that count variable. If you see, uh, if we can just run this, the chronic counts, and you can see the chronic counts. These are the chronic counts. 0 means no chronic condition. 1 means at least one of the, the disease persists, and 2 means the person has two diseases, and so on. So on the basis of this variable, we are just constructing a new variable that is a binary variable consisting either a person has a chronic condition or not. So if the chronic count is equal to 0, it will be 0, otherwise it is 1. So 0 means the person has no chronic condition, and 1 means he or she has at least one condition. So you can just run this. And now we have a qualitative variable, binary variable, that is chronic condition. And You can just run this command. That is consist of 0 and 1, and we can run the ep tool command that is required for uh, computing the odds ratios. So we have two options. One, we can use the GLM option. That is, we are running a logistic regression of the outcome. That is the chronic condition as a binary variable, and income as an exposure. Exposure means the predictor of chronic condition. So you can just run a generalized linear model with family binomial and with logit. It means we are running a logistic regression, and after that we will get the coefficients and the confidence interval for the uh, generalized linear model. If you can see, we will get this is intercept, and this is the coefficient corresponding to the high income, and this is uh, the coefficient corresponding to the don't know. Basically, we had three different groups for income: low income, high income, and don't know. So the low income group is considered in the base category. So the two groups are compared with the low income group. For example, high income group uh, will be compared with the low income group and the don't know. Basically, we are not concerned about the don't know group, so you can just skip this. But we are concerned with this coefficient. So we just exponentiate that coefficient, and that will be the odd ratio, basically corresponding to the high income. So odd ratio means the odds of having disease for a person who has high income divided by odds of a person who has a low income, odds of having a disease of a person having low income. So that ratio is basically the exponentiated coefficient. If you exponentiate this coefficient, you will get the odds ratio corresponding to this group as compared to the low income group. So just let's see. So these are the uh, exponentiated coefficient for intercept, and this is for high income, and this is for don't know category. So we are interested with this. It means the odds ratio is less than 1. It means the people in higher group has a less chance of having a chronic disease as compared to the people and uh, people uh, in the low income categories. That is expected. We were expecting basically the higher people with higher income has a low uh, odds or low probability of having disease as compared to the people belonging to low income group. And these are the confidence intervals, and you can find the p-value as well. Basically, the p-value is the p-value we already obtained here, corresponding to the uh, uh, this value. Uh, you can just find the p-value by obtaining the coefficient and then dividing it by standard error, and then comparing to the standard normal distribution. But it does not give direct p-value for this coefficient, the odds ratio. So another method is that is indirect method. We can compute the odds ratio using the table command. It will provide a 2 cross 2 table or uh, income and outcome. Basically, outcomes are 0 and 1, and these are three categories of income. So we can just name the three categories of income and three categories or two categories of the outcome. That is basically our response variable. And you need to construct a matrix of 2 by 3, 3 by 2. We have three rows and two columns. So I am just putting all these values in terms of a matrix with three rows and two columns. And by row it means first it will create complete first row, and then second row, and then third row. So I am just putting values like this: 25, and then 89, and then 17. So these are the values I just uh, read in matrix form, and you can just run this command, and you can uh, name the different rows and columns. Rows are program, and uh, that is our income. Where income name, we have already given name to different categories of income, and we have already given uh, name to the different chronic conditions, that is no chronic condition and have chronic condition. So you can just name the dimensions of the matrix, and then you can obtain the odds ratio as using the odds ratio command. But for this purpose you need the ep2 library, and this is basically under this package. So you can just run the odds ratio. It consists of the odds, the data basically we used, and the odds for height is zero point 0.8. That is the same as we get through logistic regression. And for unknown category, and we have again the confidence intervals. And now we get the p values using midpoint exact and Fisher exact and chi-square test. So these are the p-values we get. That is, uh, uh, we are just computing the association between these categories, uh, the income categories with the uh, chronic condition. So these are the p-values you need to report in your publication. So finally, you can just combine these two results, and you can just copy this in your publication. You can just select this column. You can either, if the frequencies in different cells are small, then you can report Fisher exact. Otherwise, you can uh, report this p value. So that's all about using uh, computing ordinal odds ratio for unweighted data. So in next video, I will show how we can compute the odds ratio for a survey weighted data that is required when we have a complex survey design. Thank you.